Hello. Today we'll be discussing an essential and interesting topic, simple harmonic motion. So before going into the depths of simple harmonic motion, we'll first see some terms associated. First is periodic motion. Periodic motion. Periodic motion is which repeats itself at regular time intervals. At regular time intervals. So, for example, this is the sun and this is the Earth's orbit around the sun. This is periodic. We can see clearly that this is periodic. It repeats itself at regular time intervals. So, this is an example of periodic motion. Coming to oscillatory motion. Oscillatory motion. What is the difference between periodic motion and oscillatory motion? Every oscillatory motion is periodic, but not every periodic motion is oscillatory. How? We'll see now. For example, we can quote a to and fro motion. Suppose you have a pendulum. It moves from point mean to point A, then again to point mean to point B. This is a to and fro motion, and observe carefully. There is a mean position or equilibrium position. Mean or equilibrium position present, which was not present in periodic motion, periodic motion, such as the motion of the planets around the sun. There is no equilibrium position here like we had in the oscillatory motion. Turns out oscillatory motion is to and fro motion, and there is something called as simple harmonic motion, which is again to and fro, but the force acting on it, the restoring force acting on it, will be equal to minus kx. That is, force acting on it, this is force acting on it, some constant into the distance it travels. It is also called as spring force. So this constant becomes spring constant. I'll give you an example here. Now let us see. You have a spring connected to mass m. When you pull this and leave it, what happens is this will continue this kind of motion. It will move here and here and here and here. There is a equilibrium position again. Equilibrium position. Now what happens is the force acting, restoring force, when it moves here, the restoring force acts this way. Restoring force acts this way, but it is moving here. So displacement is in this direction, restoring force is in this direction. Now when it moves back, now the restoring force is in this direction, but displacement is in this direction. So minus sign. Force is negative of the spring constant multiplied by the distance, or the displacement rather. So this is SHM, simple harmonic motion. Further to say, now simple harmonic motion is generally associated with cos, that is cosine and sine functions. So we'll first discuss how this came about. Once we have cleared, periodic motion would repeat itself at regular time intervals, such as the movement of sun around that of movement of earth that around that of sun, and oscillatory motion. For example, we have uh, uh, leaves moving under the influence of wind, or earthquake earthquake moving buildings. This is an oscillatory motion. When the earth moves, the tall buildings also sway here and here. So this is an example of oscillatory motion. And this is, now we have discussed, if this specific case occurs in oscillatory motion, this is called simple harmonic motion. Now we'll discuss the differential equation from which simple harmonic motion has been derived, or rather can be explained properly. I'll turn the page. For example, now we know that F equals ma. This is Newton's second law of motion. So F equals m d square x by dt square. A is nothing but dv by dt, change in velocity with respect to time, and v is nothing but dx by dt, change in position with respect to time. Now combining this, we get d square x by dt square equals m into d square x by dt square equals f. Now we know that this is the case occurring. What is the force acting in this case? It is the spring constant minus kx equals m d square x by dt square. So let this come to this side. It becomes m d square x by dt square plus kx equals 0. Dividing by m on all the sides, by m, by m, by m. Now these mm cancel. So d square x by dt square plus k by m, kx by m equals 0. Anything that is division by a constant gives you 0 again. So this is 0 already. Now this is actually equal to omega square. Omega is angular frequency. So d square x by dt square equals omega square x. Plus omega square x equals 0. This is the differential equation for simple harmonic motion, and you will see its solution is somewhat similar to a sine omega t plus phi. Phi is called the phase difference, nothing to worry about, we'll discuss it in the upcoming videos, or a cos omega t plus or minus phi. As we have discussed in the previous video, in the previous page rather, that it is a function of cosine or sine, and the differential equation solution is indeed a function of sine or cosine. So this is it for today. I hope you understand what is the difference between periodic, oscillatory, SHM, and thank you. Good luck.